Checkpoint 2. The figure here shows a family of parallel equipotential surfaces in cross section and 5 paths along which we shall move an electron from one surface to another. Question A. What is the direction of the electric field associated with the surfaces? And question B. For each path, is the work we do positive, negative, or zero? And the question C. Rank the path according to the work we do greatest first. Now, before we answer these three questions, let's see what is given in the figure. So in the figure, they mentioned different layers of equipotential surface we have, and each surface has different potentials. So here the dotted line is the equipotential surface. So that means the first line has 90 volt, second one is 80 volts. So likewise, each and every equipotential surface has different potential. And also they represent 5 different paths. We are just moving the electron from one surface to another surface. Clear? So that means here we are moving the electron from 80 volt to 70 volt. And here we are moving the electron from 80 volt to 70 volt. And here we are moving the electron from 80 volt to 60 volt. And in path 4, we are moving the electron from 60 volt to 70 volt. And the fifth path, we are moving the electron from 70 volt to 60 volt. So we have to use the formula very carefully. Clear? Okay, so first we can answer the first part. What is the direction of the electric field? What is the direction of the electric field? As we already studied, the electric field lines always move from higher potential to the lower potential. You can see here, the higher potential here is 70, the lower potential is 40. So your electrical field lines always moves here, move from high potential to the lower potential. So based on the figure, here your electric field lines are pointing towards rightward directions. The answer here is the electric field is towards rightward direction. Clear? So this is the answer for the first part. For the second part, we are going to find for each path is the work we do positive, negative, or zero. As we know, the formula work done, which is equal to the charge multiplied by the potential change. Clear? But here the charge is the electron, and then the potential is very important. So we are going to apply the value here. So let's take the charge here is a negative value of the charge. Okay, and then what is the potential here? So you can see here this minus that. Am I right? So that means V2 minus V1. So it's moved from 80 to 70. Am I right? So 80 to 70 is nothing but 70 minus 80. We got minus 10 volt. So which is equal to 10 times of E, and the unit for the work is joule. And then for the second part, this is for the answer for the first part. For the second part, work done, which is equal to the charge is negative, which is an electron, and let's see the second part. So it's moved from 80 to 70. So that means V2 minus V1. So here we got the answer as 70 minus 80, which is minus 10. Again here we got the answer as 10 times of E, and the unit for the work is joule. And then the third part, work done, which is equal to, you can see it moved from 80 to 60. So that means 60 minus 80 is minus 20, and the charge is here is minus E. So minus E multiplied by minus 20, we got 20 E joule. And then we have to see the fourth path, but the fourth path is different, move from 60 volt to 70 volt. So here we got W, which is equal to minus E, which is the charge. When you just use the initial to the final, so here we got 70 minus 60, we got a 10 voltage difference. That means the potential difference here is 10. Why? Because final minus initial is nothing but 70 minus 60. So here we got the answer as minus 10 E joules. And then for the fifth path, we are just having the same, which is minus E charge, which is an electron. So which is moving from 70 or to 60. So 60 minus 70 here is minus 10. So minus to minus become plus. So 10 E joules. So here all J refers to the unit of the work. So don't get confused. So the answer here we got for the path 1 work is 10E, second one is 10E, third one is 20E, and fourth one is negative 10E, and fifth one is positive 10E. So now you can see here we have to answer, is the work we do positive, negative, or zero? So based on the answer, the path 1, 2, 3, and 5 does positive work. So the path 1, 2, 3, and 5 does positive work, and then the path 4 does negative work. Clear? Because we got the answer as negative. So this is the answer for part B. Now we have to come for the part C, because we have to rank the path according to the work we do greatest first. So here, which work is greatest? You can see the third path work is 20 joules. That means this is the greatest work. Am I right? So we have to answer from the greatest to the smallest. So when you answer the part C question, so we have to see the important, we have to give the importance for the greatest first. So here, the third path does greatest work, which is 20 times of E, and its unit is joule. So the third path has the greatest work. And then path 1, path 2, and path 5 has the same work. So your third path is greatest, the second greatest, or 1 equal to 2 equal to 5, and then the last one is negative. So this is the last value, which is the fourth path. So this is the answer for this question. Clear? That's it. Thank you.